Welcome back guys. In this video, let's discuss about hormones and secondary messengers. Guys, we have already discussed what are the secondary messengers. See, the three important secondary messengers which we have discussed are cyclic AMP, cyclic GMP, IP3DAG calcium system. So, we have seen what are the secondary messengers. Now, in this video, let's see what are the different types of hormones using different types of secondary messengers. Okay. Having said that, let's start our discussion with the first secondary messenger, that is CAMP. CAMP means cyclic AMP. The important point is it is the first secondary messenger. Okay, it's the first messenger, secondary messenger to be discovered. It's the first secondary messenger to be discovered. Now let's see what are the different hormones are using this CAMP secondary messenger system. The first type of hormone is the hormones involved in metabolism. So those hormones which are involved in metabolic reactions or metabolic processes will use, not all hormones, some hormones will use the CAMP secondary messenger system for their actions. So metabolism, the hormones involved in metabolism. The second hormone is the hormone involved in water reabsorption. Okay, and the third hormone is the hormone involved in electrolyte secretion. Okay, so these three hormones or these three groups of hormones will use CAMP secondary messenger system. Now let's start with the hormone involved in metabolism. Now what is that hormone involved in metabolism using this CAMP secondary messenger system? Here itself I am writing, the hormone is called as glucagon. We all know glucagon is something which will increase the blood glucose levels. Okay, whenever your blood glucose levels are falling down, whenever the blood glucose levels are falling down, glucagon is going to be produced from the alpha cells of pancreas. Now this alpha cells of pancreas is going to produce glucagon. Now this glucagon, where it will come? This glucagon, it will come to liver and it will act on hepatocytes. Now this glucagon is acting on a hepatocyte on G protein coupled receptor. Okay. Now that G protein coupled receptor, okay, let me write it down here. In the liver, it's acting on G protein coupled receptor, which is having alpha subunit of alpha stimulatory. Okay, that is alpha S for stimulatory. We have seen. See, there is G stimulatory component, G inhibitory component, GQ component will be there, GT components will be there. What I am saying is, whenever the blood glucose levels fall down, glucagon is going to be produced from the alpha cells of pancreas. This glucagon, it will come and act on the hepatocytes on which receptor? On G protein coupled receptor, which is having a subunit of stimulatory GS or alpha S. Now what will happen? Now inside the cell, this alpha subunit, whenever it is activated, it will detach from beta and gamma subunits, which we have already discussed in the previous video. Now this alpha subunit, this alpha S stimulatory subunit, it will separate. It's having the GTPase activity. It will convert GTP into GDP. Energy will be released. With the released energy, it will activate adenylyl cyclase. Okay, adenylyl cyclase is activated. Now this adenylyl cyclase is going to convert ATP into CAMP. Now secondary messenger is produced inside the hepatocytes. Now this CAMP is going to activate protein kinase A. Protein kinases are activated. Now protein kinases, what they will do? They will do phosphorylation of necessary proteins. So at the end of the day, what's happening? See, now glucagon is acting on the liver. Now when glucagon acts on the liver, now inside these hepatocytes, adenylyl cyclase is activated, CAMP is produced. So secondary messenger is produced inside the hepatocytes. Now this secondary messenger at the end of the day helping in glycogenolysis. So because of the glycogenolysis, the glucose levels in the blood will be elevated. So glucose is getting elevated in the blood because of glucagon. So what I want you to know is this glucagon, which is involved in a metabolic reactions. Now it's using which type of secondary messenger inside the cell? CAMP. Now what the CAMP is doing? It will activate necessary proteins for the process of glycogenolysis. So because of glycogenolysis, blood glucose levels are elevated. Simple. Same like this. Now let's see, what is this water reabsorption? What is the hormone that's involved in water reabsorption? We all know the hormone involved in water reabsorption is antidiuretic hormone, okay, also called as simply ADH or vasopressin, okay. Now see guys, this antidiuretic hormone, whenever it's there in the body, okay, first of all, whenever the person is getting dehydrated or when the person's plasma osmolarity is increasing, now what will happen? Antidiuretic hormone is going to be released from the posterior pituitary. Now what this antidiuretic hormone will do? This antidiuretic hormone, it will come to the collecting ducts, okay. Now in a collecting duct, it is going to act on a cells called as principal cells. Okay, let me show you one principal cell over here so that it will be easy for you to understand. See, this is a nephron. Part of the nephron I am showing you is collecting tubule or collecting duct. Now here I am showing you one cell which is a principal cell. Now antidiuretic hormone came here. Now this antidiuretic hormone, definitely it cannot cross the cell membrane, okay, it cannot cross the cell membrane. So now it's acting on a receptor, okay, on the cell surface, okay. Now this receptor is called as V2 receptor, okay, which is nothing but G protein coupled receptor, okay, it's a GPCR, that's a G protein coupled receptor. So definitely it's going to be a 7-pass receptor. Now inside here there is alpha component, beta component and gamma component. Let's talk about the alpha component. The alpha component here is alpha stimulatory, okay, or G stimulatory component. Now what happens? This antidiuretic hormone, it will come and bind to the ligand binding domain. Now this V2 receptor is activated. When V2 receptor is activated, what happens? Now this alpha subunit is going to detach from here, it will move away, converts GTP into GDP with whatever the energy release, it activates what? It activates adenylyl cyclase inside the cell. Adenylyl cyclase is activated. Now in this cell, whenever the adenylyl cyclase is activated, here adenylyl cyclase is going to convert ATP into CAMP. So CAMP levels inside the cell are going to be increased. Now whenever the CAMP levels are increased, it will phosphorylate, okay, it will help in activation of protein kinases. So protein kinases are activated. Whenever the protein kinases are activated, it will cause phosphorylation of necessary proteins involved in water reabsorption, okay. Now what it will do is, at the end of the day, it helps in production of water channels. It helps in production of water channels because of the elevated CAMP levels in the cell. After this CAMP is produced, a cascade of reactions will take place in the cell. which ultimately helps in the production of these water channels. Now, these water channels will help in absorption of water into the cell. Okay? Water is being reabsorbed into the cell. So, what I am saying is, antidiuretic hormone acts on V2 receptors. Now, what exactly is this V2 receptor? This V2 receptor, is it a type of G protein coupled receptor? Is it a tyrosine kinase receptor? Is it a serine kinase receptor? Or is it a Janus kinase receptor? It's an example of G protein coupled receptor. Which type of G protein coupled receptor? This is a type of G protein coupled receptor where intracellularly it is having G stimulatory component, G stimulatory alpha component. So, whenever antidiuretic hormone acts on these principal cells, what will happen is that CAMP levels will be elevated. The CAMP levels will activate protein kinases. Now, there are certain proteins which are activated. Ultimately, water channels, aquaporin 2 water channels will be implanted on the luminal surface of the principal cells. At the end of the day, water reabsorption will be happening. And the third group of hormones which are using the CAMP system is involved in electrolyte secretion. Now, what is that hormone? It is, let me write it down here, electrolyte secretion. Okay. Now, this electrolyte secretion is done by which hormone? The first hormone is secretin. Now, what is the first important point about the secretin? Guys, the secretin is the first hormone, not first secondary messenger, first hormone to be discovered in humans. Okay, it is the first hormone to be discovered in the humans, and the secretin is also called as nature's antacid. Okay, so it's a nature's antacid. Why it is called as nature's antacid? Because see, secretin, first of all, who is going to produce a secretin? This is the esophagus. Here I am showing you the stomach, greater curvature and lesser curvature of the stomach, and this is the duodenum. Now, in the duodenum, there are cells called as S cells. Now, these S cells are the ones who are producing these secretin molecules. So, whenever you eat food, that food is going to mix with the acid in the stomach. Now, whenever the food, the chyme, whenever the chyme, partially digested food, whenever it enters into duodenum, now that acidic chyme, that acidic environment, that acidic pH will stimulate the S cells in the duodenum to release secretin. Now, this secretin is going to come and act on pancreas. Okay, it's going to come and act on organ called as pancreas. Now, pancreas is going to produce alkaline rich pancreatic juices. Okay, alkaline rich pancreatic juices are getting produced. Now, what exactly secretin is doing? Secretin, by acting on pancreatic cells, making the pancreatic juices more alkaline, which means upon action by the secretin, now the pancreatic cells are throwing more bicarbonate molecules. Okay, so more, here the electrolyte is nothing but the bicarbonate. When secretin acts on pancreas, now secretin is helping in putting more bicarbonate molecules or more electrolyte secretion. This bicarbonate is an electrolyte. More bicarbonate is being kept into the pancreatic juices. So, the pancreatic juices become more alkaline. Okay. So, this is what I want you to know. Very simple. See here. Secretin. Now, secretin, whenever it's acting on pancreatic cells, Okay. The important point which you need to know is, see, here is a pancreatic cell. Now on this pancreatic cell, there is a receptor for secretin. Definitely this receptor is also 7-pass receptor or serpentine receptor. Secretin molecule is coming and binding over here to the ligand binding domain. Now whenever secretin binds here in this domain, the alpha stimulatory component will be activated. Okay, alpha stimulatory component will be activated. Now this alpha stimulatory component is going to activate adenylyl cyclase inside the cell. Now that adenylyl cyclase increases the CAMP levels. Now the CAMP is helping in throwing out more bicarbonates into the pancreatic juices, making the pancreatic juices more alkaline. So at the end of the day, the one single point which I want you to know is secretin increases the CAMP levels in the cells. Secretin, by acting on its receptor, brings out or increases CAMP levels in the cell, or CAMP is acting as a secondary messenger for secretin, helping in releasing more bicarbonates, making the pancreatic juices more alkaline. So having said that, I have discussed the 3 important hormones which are utilizing CAMP as their secondary messenger. What are these three important hormones? First hormone is glucagon. Second hormone is antidiuretic hormone by acting on V2 receptors, helping in water reabsorption. And the third important hormone is secretin by acting on pancreatic cells, helping in more electrolyte secretion. Okay, that electrolyte which I have discussed is bicarbonate. One more important point, not only hormones like secretin uses the CAMP for more electrolyte secretion. One important point is toxins like cholera toxin and pertussis toxin. Okay, these two toxins, cholera toxin and pertussis toxins, will also uses CAMP. Okay, so these two toxins increases the CAMP levels inside the cell. See, cholera toxin, it can stimulate the G protein coupled receptors. Now it increases the CAMP levels inside the cell. What it will do is, right now I am talking about the cholera toxin. Okay, let me show here. Cholera toxin, what it is doing? It is increasing the CAMP levels. Now what the CAMP will do is, CAMP here will increase the electrolyte secretion. Okay, now into where? Into pancreatic juices? No, here cholera toxin increases the CAMP levels in the cells, in the JAT cells, increases the electrolyte secretion. Who is the electrolyte here? Here electrolyte is sodium chloride. Now sodium chloride is getting more and more secreted into stools. Now what happens? Now stools are going to be having more and more this NaCl, so that wherever there is sodium, there water follows. So when so much amount of sodium chloride is being secreted into stools, there will be diarrhea. Okay, now why there is diarrhea when a person is having cholera? Vibrio cholera, it produces a toxin called as cholera toxin. It enters into the cell. Now this not enters into the cell, it stimulates the G protein coupled receptors. Now this G protein coupled receptors are going to increase the CAMP levels. Now the CAMP levels will increase the electrolyte secretion. The electrolyte here is sodium chloride. More and more sodium chloride is being secreted into stools, so there will be diarrhea. In the same way, almost just like this, pertussis toxin will also act. Let me write it down here, guys. Pertussis toxin. Pertussis toxin will also increases the CAMP levels, but here the mechanism is a little bit different. Let me show you. Normally, CAMP levels are increased by, let me show you here. Normally what happens? Whenever you stimulate a serpentine receptor, see here is the alpha stimulatory component. Whenever you stimulate this receptor, the 7-pass receptor, this is the cell. Okay. Now this alpha component is going to be detached. It activates an enzyme called as adenylyl cyclase. Now this adenylyl cyclase converts ATP into CAMP. Okay. Now the CAMP will activate protein kinase A or the other types of protein kinases. Now see here, this alpha stimulatory component or the G stimulatory component always increases the CAMP levels. But remember, the CAMP levels will be decreased or the adenylyl cyclase will be inhibited by other type of receptor. Okay, let me show you here the other type of receptor. Okay, let me show you with a different color so that it will be easy. See, this is also a 7-pass receptor, but here the alpha component is G inhibitory type or alpha inhibitory type. Whenever you stimulate this receptor, what it will do? It will go and inhibit adenylyl cyclase so that CAMP levels will be going down inside the cell. Okay. Now, what our pertussis toxin will do? Our pertussis toxin will inhibit this. Okay, just give me a minute. Yes, our pertussis toxin will inhibit this G inhibitory component or the alpha inhibitory component. Whenever the alpha inhibitory component is inhibited, what will happen? Adenylyl cyclase is now active. Adenylyl cyclase is just active. There is no one to inhibit the adenylyl cyclase. So when adenylyl cyclase is continuously activated, CAMP levels will be increased. So that's how pertussis toxin will increase the CAMP levels. So pertussis toxin, it inhibits G inhibitory component or alpha inhibitory component. Whenever there is whenever the alpha inhibitory component is inhibited, automatically CAMP levels will be increased. Okay. Guys, we have discussed all the important points about the CAMP. Now after seeing about the CAMP, in the next video, let's discuss about the secondary messenger, that is the calcium IP3 DAG calcium system. Okay guys, see you in the next video.